In this video we're going to track down the source of a transient EMI problem on the circuit board, and we're going to use this mixed domain oscilloscope to look at frequency domain and time domain characteristics to track this down. I'm also using this little near field probe. This one happens to be by a company called Beehive Electronics, model 100C. Really nice little near field probe that allows you to look at the near field emissions that are going on a circuit board by just hovering over various areas of the board. You'll notice if I hover over the switching power supply over here, I can see some of the harmonic generation from the switching power supply there. But the transient signal I'm interested in is occurring just on the north side of this FPGA. And if I lay the probe right in here just right, okay, you can see this signal right here at about 137 megahertz. That's popping up every once in a while, about 10 or 15 dB. Okay, that could be a really tough thing to track down. It might be one of those things that causes you every once in a while to fail an EMI test. But what we can do is, since we're really tightly coupled to it, the likelihood is that we'll be able to use the RF power trigger on the spectrum analyzer to trigger when that occurs, so we can start to isolate that. So what I'll do is I'll go to the spectrum mode and change the spectrum from free run to triggered, and change the threshold and start moving it down until I start seeing that spectrum occurring. So now if I take a look at it, now I'm triggering actually when that signal is occurring. I can actually see it occurring pretty regularly here at about that minus 40 dBm level, as opposed to when we were running kind of free run here, we saw it kind of bouncing back and forth. So now I'm triggering specifically on that event. Okay. What we can then also do is add an RF amplitude versus time trace. That's one of the beauties of the mixed domain scope, is we can add amplitude, frequency, and phase variation over time. So if I turn the amplitude versus time trace on here, so now this trace right here is time domain, is showing me RF power versus time. And I can see distinct little impulses or blips here that are occurring. If I do a single capture here real quick, we can go take a look to see, is this blip indeed this signal here at 137 megahertz? Where we're looking at the spectrum right here, it's at minus 40 or so dBm. If I move the spectrum to in between these two blips, say over into this area, I can just pan that over. Okay, now that signal is about minus 52 dBm. So it dropped about 12 dB between here and here. Let's move the spectrum over to this location where the previous blip was to what I triggered on. Okay, and if we take a look at that, there's my signal back there at minus 41 dBm again. So we can actually see that this thing is repetitive, and if we look over at this one over here, same thing, we'll see the signal's there about minus 40, in fact minus 39.9 dBm right there. So I know I'm triggering on that event. I can see it's got a regular pattern to it. Now the nice thing is, now that I can see that, let's go back and go run this again. So I can see this thing is occurring at a regular rate. So now all we need to do is to take a look on the board to see if we can find a signal that's coincident to that event, and that'll give us the keys that we need to go understand what the mechanism might be that's behind this bursted RF transmission. So I'll add channel 1 and just take my probe here, and it's very easy for me to go around and probe various areas on this board. If I probe this header over here, okay, I can see a signal there that is kind of somewhat random and not at all coincident to that particular event. If I look at that signal there, I can see that one. If I look at this one here, again, it's kind of a random signal. It's not coincident to that event. Okay, but if I look at this signal over here, this one quite clearly is very coincident and synchronous to that particular event. Let's just do a single shot capture on that, and it's very easy to see that this little bursted signal is occurring right at the same time I'm getting this RF signal here. You may notice that I was probing over here, and the RF signal I'm looking at is way over here. And this kind of points out the fact that sometimes the signals that may be coincident to these events might be as a consequence to something else that's going on. For example, this FPGA could be doing something in its code to generate that signal, but it's that the work that it's doing in the FPGA that's causing an emission that could be at a signal that's completely unrelated to the frequency that we see at the probe test point. But at least understanding what the circuit was up to and what signals were being generated, or where it was in its state machine or whatever it might be, may give you the key to understanding the source of these emissions, so that you might be able to retime things a little bit better to maybe reduce some of those things. So I hope this was helpful, and kind of shows a neat use of a mixed domain oscilloscope to track down a transient EMI problem.